Okay, so this was a problem that I was having at the end of last year. What I would really like to have work, and we're going to see if this works. We'll post it in the end of class and see if we actually get sound. What I would really like is this is a special microphone that I can wear and it picks up my voice. Right now, I think that what's happening is there's a little tiny camera on my desk, and I think that's the one where it's trying to pick up the sound. So if you're really loud during class, it's going to pick you up more than me, which could be a problem. So I think it's working, but the problem with that microphone is if I'm over here, it might not pick me up as much as over there. So we'll test it out. Now, these YouTube videos, they, like this first lesson is really easy. So I'm probably going to get 0 views. Most likely get 0 views on this one. I consider one of my YouTube videos, I say that it has gone viral if it gets more views than the amount of kids that were in the class. So if I have a video with like 35 views, it's like that thing went viral. That's my definition of viral, not, but I do have, yeah, I'll show you it later. I do have some videos that have gone crazier than I thought they would. Like, not crazy, but like crazy, like more than 35. Okay, so here's our first unit. It's all about measurement. The activity that we did yesterday got us into the idea of converting things from one thing to another. We converted money from Canadian dollars to Australian dollars to US dollars, and a lot of conversions happen in measurements, and that's because we have a metric system and an imperial system. The imperial system, inches, feet, yards, and miles, right? And we still probably use inches and feet quite a bit. Probably don't use yards very much as much anymore, and even miles. The only time you have miles per hour now is if you would go to the United States, but not so much in Canada. The metric system uses centimeters and meters. And Canada used to use inches, feet, and yards for everything, and then they switched. Probably they switched sometime in your grandparents' era. You might ask them, when you were in school, did you use feet and inches, or did you use centimeters and meters? And what was it like to switch? Because they had to change all the road signs. And then when you had to be like, how far are you away from the next town, that sign had to change because they changed it. It used to be in miles, now it's in kilometers. Now in the metric system, we have our basic units, like for length, that's your meter. For volume, that's a liter or a cubic meter. And for mass, that's the gram. And we have symbols M, L, G for these. And then with that, we can put something in front of that. A megagram. That would be 1 million grams. That would be pretty heavy. Okay? Probably more used to a kilogram. A kilogram, the K stands for 1,000. Same thing with kilometer. A kilometer is 1,000 meters. A kilogram is 1,000 grams. A kiloliter would be 1,000 liters. Then there's some that we don't use very much. Like kilometer, kilogram, you use that a lot, right? Hecto, deca, right? You don't hear those used very often, but a hectometer would be 100 meters. A decameter would be 10 meters, right? When someone wants to, like, nobody ever says, oh, I'm going to go out and run the hectometer race, right? It would be, maybe we should, but like, oh man, that guy has the, like Olympics, can you imagine if they told, they like, we're going to change it. where you're not running the 400 meter anymore, you're running the 4 hectometer.
That'd be just goofy.
It would be weird, right? Because we're not used to it, right? Right, so these ones we don't use very much. Decimeter, don't use that one very much. But centimeter, that one we use quite a bit, right? We don't use centigram very much. You never hear of centigrams. We hear milligrams. Lots of your medications, if you have to have, if you're taking an aspirin or you've got a headache and you need a Tylenol, you'll notice on there the ingredients, they say how many milligrams of something they have in there. So milligrams. And then you get really small, and you have micrometer, microgram would be really, really, really light. And it uses, this is like one of my favorite Greek letters. Does anyone know what this Greek letter is called? This is the Greek letter mu. And why I like it so much is because the way that you draw it, okay, the Greek letter mu, can you see the letter U?
Yeah.
Can you see the letter M? And then it's like letter, and it's the letter mu. I don't know. I think that's cool. But it's pretty cool. I like this one too. Anybody know what this one's called? Any guesses by the letters you see? N. It's got a little U at the bottom. I don't know. That's the letter U. Anyway. Mathematicians like to use Greek letters. So for conversions, we know that 1 kilometer is equal to 1,000 meters. So just like we were doing conversions in money before, we can do either one of those two techniques that I showed you for the money the other day. One of the techniques was you use your intuition and you either have to multiply or divide. In this case, 100 kilometers, the conversion is 1 kilometer is 1,000 meters. Should I multiply or divide? Should I multiply the 100 by 1,000, or should I divide the 100 by 1,000? We're going to multiply. So 100, if I multiply by 1,000, will give me 3 more zeros, will give me 100,000 meters. Okay? Part of the intuition of whether I should multiply or I should divide when using the conversion is sort of, well, which one's bigger, which one's smaller? Kilometers are bigger than meters. So if these are going to be equal, wouldn't you need a lot more meters to be equal to the kilometers? Because the kilometers are bigger, so you would need a lot more meters in order for them to be equal. If I multiply, I will get more. If I divide, I would get less. So that can help you a little bit with the intuition. If you are dealing with something that's a little confusing, and I did the currencies at the beginning because sometimes I would say currencies can be confusing, especially when they're close. Then we can use ratios to figure this out. We don't know how many meters, so we put an X. I don't know how many meters is 100 kilometers. But I know if they're equal, and you have two things that are equal, and you divide them, they're equal to 1, right? It's really easy if the numbers are the same. 13 divided by 13, 1. 72 divided by 72, 1. If the numbers are exactly the same, it's easy. But if we are dividing two things that are equal in different, like 1,000 meters divided by 1 kilometer, since they're equal, that's equal to 1. So in setting up the ratio, I set up this, which is equal to 1, and on the other side, I set up In the same way, meters on the top and kilometers on the bottom, well, I know that 1 kilometer is 1,000 meters. And now I have something that I can solve an equation mathematically. Okay? If I wanted to get this by itself, can you see that I would have to multiply by the 100 kilometers? And if I multiplied the other side by the 100 kilometers, that's mathematically what you do with an equation. What you do to one side, you do to the other side. Notice that the multiplication that we did as a shortcut appears. 1,000 times 100 divided by 1. And what is also, I think, pretty cool as far as solving this is notice that, did you know in math, if you have the same thing on the top and bottom, that they simplify and just become 1? Like if you were doing some tough mental math, how's your 17 times table? Pretty good? Yeah? Everybody's like 17 times 19? Everybody good? No. No? 323? I'm going to have to check that. 17 times 19. Then, if I divide by 17 though, can you see that, oh, that's 17 divided by 17, that's 1. That answer would just be 19. I don't have to first do 17 times 19, get 323, and then go, okay, what's 323 divided by 17? That's 19 again. And in math, sometimes when we put a line through it sort of to cancel it out, technically these cancel out and both become 1s, because 17 over 17 is 1 over 1. What's really cool with units is technically the kilometers cancel out, because you did kilometer on the bottom, kilometer on the top. And what are we left with? 100 times 1,000, and it's meters, which does the conversion nicely. So those are some technical things in here, but the idea is you can either do a shortcut, which is either you multiply or divide, and you have to say which one makes sense in this situation. That's a great way of the shortcut. However, sometimes that shortcut doesn't work for us because we're like, I'm confused. Should I multiply? Should I divide? I'm not sure. Then the ratio is a really nice way to make sure you're doing it right. So let's look at the next one. We've got millimeters and centimeters. So you would have to know what's the relationship between millimeters and centimeters. Sometimes these things, it's really helpful to think of a ruler, right? On a ruler, do you know what a centimeter is? Do you know what a millimeter is? Which one's smaller? The millimeter. How many millimeters are in a centimeter? 1 centimeter is 10 millimeters. So we have our basic conversion here. Then when we go here, should I multiply or should I divide if I'm changing from millimeters to centimeters? Divide. I divide. So 100 divided by 10 gives me 10, and I've got my answer using the shortcut. Okay? I should think though, like, does this make sense? Millimeters are smaller than centimeters, so I would need less centimeters to be the same as the total amount of millimeters. So that's our shortcut. We figured out we should divide instead of multiply in this situation. If I didn't know, and I'm trying to solve how many centimeters, and I set up my ratio, is 100 millimeters, and I know that 1 centimeter is 10 millimeters. So when setting up your ratio, I always like to put what I don't know on the top of my fraction, And it's supposed to be equal to 100 millimeters, so making this ratio, this should equal 1. And I already know that 1 centimeter is 10 millimeters, so I can make another ratio that's equal to 1. And I make sure that I set it up so centimeters are on the top, millimeters are on the bottom. Whatever you put on the top on one side of the ratio, we'll put that on top on the other side of the ratio. Then if I want to get the x by itself, I would have to multiply by 100 millimeters. Right? That would simplify on this side and go away. And I also multiply by 100 millimeters on this side. And now on the right-hand side, what do I have? I have 1 times 100 divided by 10. So the ratio shows the shortcut as well when we're done. One of the hard parts is recognizing what we're dealing with and knowing what they're equal to. Right? We've got milliliters and liters. So off to the side, we have to figure out liters. Maybe I'll make the L fancy like that so it doesn't look like the 1. We have liters and milliliters. Which one's bigger? The liters. So if I had 1 liter, that's the bigger one, I should have a lot more milliliters. What did the M, the milli, was it 100, was it 10, was it 1,000? What did the milli represent? 1,000. Okay? And now you're lucky because a lot of these measurements, you have something in real life that you've dealt with these. Okay? How many of you have ever drank a bottle of pop? Have you ever looked at how much is in there? You have no idea, you just drink it. Right? There often says like you can get 750 mils. One of the ones in the machine are what, 591? Who came up with 591?
Regular cans are like 288 or something.
But then you can get big bottles. What is the big bottle of Coke? How much is in there? 2 liters, right? So you have an idea already, because you've dealt with these things, that a relationship between milliliters and liters. Used to be nice when the bottles were 500 and the liters were 1 liter and 2 liters, and it was like, oh, 2 of these equals 1 of these. But now all the numbers are strange.
In the UK, it goes by deciliters or something.
They use the deciliter?
I think so.
Oh, man.
100 cans or whatever. So it's really
So we have this idea already. Now the question is, should we multiply or should we divide if we're using the shortcut? What do you think? And then if you're like, ooh, I don't know what I should do, multiply or divide, then you should go to the ratios and use the ratios method. This one, okay, if you multiply, you will have more. If you divide, you will have less, right? Should we have less liters than we have milliliters? Yes. So we need to divide. Now, dividing by things with tens, hundreds, thousands, 10,000s is really easy to do. You know that, like, if you had to take 82 and divide it by 10, do you know the quick way to do that? 8.2, right? You move the decimal over once when you divide by 10. If you divide by 100, you had 82 divided by 100, right? You would get 0.82, right? 0.82. You got 82 out of 100 on a test. You would have 82%, 0.82. You move the decimal twice. If you're dividing by 1,000, you would take this decimal place and move it once, twice, 3 times, and get an answer of 0.150 liters. Now, in writing that, I would not have to write this last zero, because that's kind of, doesn't matter. I could just write 0.15. I did it this time because we started with 150, and I really wanted to show you that moving of 3 decimal places over to the left. Again, we could do our ratio. I want to solve for liters. I know that I have 150 milliliters. Put liters on top, milliliters on the bottom here. I know that 1 liter is 1,000. I would have to multiply both sides by the 150 milliliters, multiply this side by the 150 milliliters. Are you used to or have you seen the dot for multiplication? So what do you use for multiplication in elementary school? An X. Why did they stop?
Because X can be a variable.
Because X is, they got algebra, right? Oh. So then they started with the asterisk, okay? Mathematicians, we are inherently lazy. What's the problem with an asterisk? It's like, so many lines. I'm like, I'm exhausted. So, oh yeah, that's easier, right? But then we run into problems. Is this multiplication? Is it a decimal? So, right, is it an X? Is it a multiplication? So, math sometimes runs into problems because we start using more than one thing to say the same thing. So you have to know a little bit about the context. But now, if we multiply, we would have 1 times 150 divided by 1,000, you'll get the same answer. How many of you have, from grade 9, the calculator from the school, the Casio one? I really like the Casio one because of this button where it has the S to the D. Have you used that button? Okay. What it does for you is, right, you can do 150 divided by 1,000. Push it once, it gives you the decimal. Push it again, it gives you the fraction in lowest terms. You can just toggle between different things. Really nice for that. Oh wait, sorry. I would like you to try these next 3 on your own.
Do you still have those?
So the first one, there is 1 centigram is 10 grams. And what Ms. Moore said is excellent idea. Maybe you're not as good in grams, but do centimeters, centimeters to meters, and then you do a better job. 1, there we go. Should have done it. 1 gram is 100 centigrams. Because if you think meters, grams is like the meters unit, centigrams is like centimeters, 1 meter would be 100 centimeters, so 1 gram would be 100 centigrams. Then going from that, should we multiply or should we divide? 15 grams, right, would be multiply 1,500 centigrams. Meters to kilometers. 1 kilometer is 1,000 meters. Should I multiply or should I divide? Divide. If I'm dividing by 1,000, that means that decimal place is moving once, twice, 3 times. 15.677 kilometers. And then moving from centiliters to kiloliters would be like moving from centimeters to kilometers. Now, if you go to your chart here, okay, we are moving from cent of something to kilo something. And each time you go up, it's 10 times more, right? So, 10, 100, 1,000, 10,000, 100,000. Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 10, 1, 100,000. 5 zeros, because we went up 5 times. So going back to that question, we can say that 1 kiloliter, 1, 2, 3, 4, 5, is 100,000 centiliters. Multiply or divide, right? We're going from the big one to the small one. We would need a lot more, okay? I'm going to write it in 2 different colors here, just to help you see it. We have the 150. If I'm going to multiply by a 100,000 with 1, 2, 3, 4, 5 zeros, when you multiply, you're going to have 5 more zeros. This looks like a big number, but I add the commas. 15 million centiliters. That is a lot. 150 kiloliters, that's a lot of liters. You are going to get a formula sheet for this class, and some conversions are on that formula sheet. Some I hope you know already. Like, I hope you know that 1 foot is 12 inches. But I bet you there's not very many people in here who are like, oh yeah, 1 mile is 5,280 feet. Or 1 mile is 1,760 yards. Did you know that 1 yard was 3 feet? That in 1 yard there's 36 inches? And so we're going to be converting within yards to feet, feet to yards as well. And again, I will start off by doing both methods. Okay, we can use the shortcut method. If you're using the shortcut method, first of all, you have to make the relationship between yards and feet. We know that 1 yard is 3 feet. And then you have to decide multiply or divide. Should I have more or should I have less? Okay? And when I ask you these questions, like, I'm not wanting someone to put up their hand, but I want you to be, like, in class, I want you to sort of be ahead of the game. Try to answer it in your head before you see it on here. Because you're checking yourself. You're checking to see, do I get this or not? If you can answer it in your head beforehand, and when I say, we multiply, so 7 times 3 is 21 feet, then you can kind of like, little smile in the back of your head, like, okay, I'm getting the shortcut, right? If you're unsure, like, I don't know if I should have multiplied or divided, go to your ratios. We want to find out how many feet is 7 yards. What do we know? We know that there are 3 feet in 1 yard. What would I have to do to get x by itself? I would have to multiply both sides by 7. And so then I would get 21 feet. 7 times 3 divided by 1. 7 yards to inches. What do I know? 1 yard is 36 inches. Should I multiply or should I divide? I would like to multiply here. 7 times 36. Ooh, someone have a calculator? Is that right? Yeah, okay, good. 252 inches. If we were setting it up, we wanted to find X inches is equal to 7 yards. And we know that 36 inches is 1 yard. Again, if you got the shortcut, don't forget about the ratio. Because I guarantee there will be some times that you're doing a conversion somewhere where you're like, my head just isn't working for me right now. What could I do instead? Then the ratio is really nice. This question is a little bit different. If someone said they were 62 inches tall, you would say, okay, but what is that in feet in inches? Because that's how normally someone says, I'm 5'10", I've got an idea of how tall they are, right? If someone says, I am, because I'm used to that. If someone says, I am 30 inches tall, I'd be like, I don't really know how tall that is. But if they said, oh, I mean, 2'6", you're like, oh, okay, you're just a little kid. You're 2'6". Someone who's really small, maybe that would be, when were you 2'6"? How old do you think you? So like a 3-year-old? 3-year-old, 2'6"? Right? Oh, the good old days when I was 2'6". Right, so it's 62 inches to feet and inches. How would we go about this? Okay? Can you visualize it? Here's a person, this is 62 inches. That's how tall they are from there to there. What do we know? We know that every time you have 12 inches, that's equal to 1 foot. Can you visualize how many of those 12s you would need? Right? You can count by 12s. 12, 24, 36, 48, 60, 72. Oh, I'm past it. See, I counted by 12s. I got to 72 would be 6, but 62 would have been 5 of them. So we could do it this way. We could say, well, and if I went 5 of them, 2, 3, 4, 5, we're going to pretend those are all the same and all perfectly symmetrical. You guys, you're going to have a good imagination sometimes in this class. We would have 5 of them, and that would go up to 60 inches. And then you would need 2 more to get 62. So this is a visual, and in this visual, I could say that 62 inches is equal to 5 feet and 2 inches. That visual was okay because we didn't have big numbers, right? But it would be a little bit more annoying if I asked, okay, our next question is, what is 8,382 inches in feet and inches? You would not want to be counting by 12s until you got close to 8,000, but I don't even know what number I said again, right? So let's say, what would be another way that we could help figure this out? So we did one way, right? But the problem with the one way is if the numbers were bigger, it might be annoying. So technique number 2. If I wanted to find out how many whole feet were in 62, I know that if I took 62, and every time I have 12 inches is 1 foot, I could do 62 divided by 12. Do that in your head, and, well, no, do that on your calculator, and you will get what? 5.16 repeated?
Yeah.
Perfect. So we get 5.16 repeated. This means that we have 5 full feet and a bit extra. So when I would be solving this question this way, I would probably write out, I would start by writing out, I have 62 inches, and I wanted to equal a certain amount of feet and a certain amount of inches. And I just figured out that there were 5 full feet. To figure out what's the extra, I would have to say to myself, well, how much is 5 full feet? When we did it this way, we counted, and we got to 60. Right? We could also just do, well, 5 feet is exactly 60 inches. I started with 62 inches, minus 60 inches would leave me with 2 inches left. That would work with our 8,000 one, right? Because if I took 8,382 and divided by 12, that one for sure we're going to need a calculator for, I would get a full number and a decimal. The full number is how many full feet I would have. The decimal says I have some extra. To figure out how many extra, I figure out how many is 5 feet exactly, 60 inches. Can you see then that you had 2 extra inches once you took those 60 away? This is a different kind of conversion, because now we're not converting exactly. If we were converting exactly, 62 inches is 5.16 feet. That's exact. 116 repeated. Have you seen this symbol where you repeat a number, put a bar over top or a dot over top? Good. Okay? 92 inches to yards, feet, and inches. This is how I would set it up. I have 92 inches. I want to know how many yards that is. Then there's going to be some extra that I can change to feet, and then some extra that I can change to inches. I can visualize this using the first technique. I've got 92 inches. That person is really tall. Right? I don't know if you can imagine it. Right? If we do feet in inches, that's like 7 foot. 7 foot 8 or something like that. Yeah, that's super tall. I don't know anybody who's 7 foot 8. But if we wanted to first do yards, we have to say, well, every 36 inches is 1 yard. How many of those would you have? 2, right? 3 would be too much. Can you see that if I had 3 of those yards, that would be past 92, but 2 would be perfect. So I would say, I know that there are 2 yards. I did that from my diagram. I could also find out that there's 2 yards by saying, well, how many 36s fit into 92? I go to my calculator, and I take 92 divided by 36. I get 2.5 repeated. This tells me 2 full yards, and 0.5 means there's some extra. So I know that there's 2, but I need to find out how much extra. 2 yards, 1 yard is 36 inches, then 2 yards is 72 inches. 92 inches is what we started with. If we take 2 yards off, we take off 72 inches, we would have 20 inches left. That's the extra. I now have to find out, in that last 20 inches, is there any feet in that? Or do I just write 20 here? Should I put 0 feet and 20 inches? Or is there, in 20 inches, is there a foot? Yes. Because every 12 inches is 1 foot. So now I'm imagining, I've done my 36 and my other 36, and I know that this part that's left is 20 inches. And I know that 1 foot is 12 inches. Okay? So if I have 20 inches left, how many 12 inches can I get in there? Only 1. So if I thought of it that way, I could say for sure there's going to be 1 foot. I could also have done that by saying 20 inches divide by 12, that will give me 1.6 repeated. I think. Double check. Yes. So I know there's 1 full feet. How many is left? Well, I would have to take the 20 inches and subtract 1 foot, which is 12 inches, leaves me with 8 inches left. If you want to check your answer, you could change each of these things back to inches to check. 8 inches is obviously 8 inches. 1 foot is 12 inches. 2 yards is 72 inches. If I add the 72 plus the 12 plus the 8, does it add up to 92? Yes. Right? These can be tricky because we're doing a lot of thinking as we go along. And again, if you just try to memorize how to do this, you're going to run into problems because you should understand, you should be thinking and saying, this makes sense to me what I'm doing. So this check at the end can be very nice. All right, we got a couple of problems here. We're almost done. We're going to get, I think, hopefully get the last question or two done. If we don't, we'll finish it up on Monday. But you will notice, and I'll get you just to turn ahead a little bit. Notice at the bottom of page 7, there's a homework exercise. It's on page 11 from your textbook, and it has some questions listed there. You are going to be able to do those already. We've done enough in this class already, even if we haven't done the last examples. So that should be done for Monday. So you've got your first homework assignment. Math is something where you get better at it by practicing. So I'm not taking this homework in for marks. Okay, I might ask to see it on Monday. But for yourself, know that the more you practice now in grade 10, the easier your life is going to be in grade 11, and the easier it is going to be in grade 12. Right? In fact, if you could go back and tell yourself, your middle school self, hey, practice your times table. I'm going to need it in high school. I'm going to use it a lot in high school. What were you thinking, little grade 8 kid or your little grade 7 kid? You shouldn't go back in time and choke yourself, but you should have learned your times table better. But you can't go back in time and do that now. But you can start right now for grade 10. In whatever subject you are, the more effort you put in now, the easier your life gets in the future. And as a teacher, that's what I want to do. I want to make your life in the future the best it can be. So I'm telling you already that the effort you put in now in grade 10 will help you next semester in grade 11. It will help you in grade 12. And it might even make a difference in what career you go in the future. Instead of getting a job that pays X amount of dollars, you make a little bit more money, which I think would make you happy if you had more money versus less money. I think that's one of those good things. So, solve a problem that involves conversions. Ben is buying baseboards for a bedroom. You know, baseboards are like the black stuff that goes around here. It's just makes it nice around the edge. And he measured his whole perimeter of that bedroom and came up with 37 feet. Question is, what is the length of baseboards that are needed in yards and feet? So we have 37 feet, and we want to figure out how many yards and how many feet is this. So it's very similar to the last question that we did. What do we know? Well, we know that in 1 yard, from our chart at the beginning, is 3 feet. And so every 3 feet, you get 1 yard. So if we take 37 and divide it by 3, go to our calculator, type that in, or if you like doing mental math, you can do that as well. You get 12 decimal something. Maybe you can see that there's 12 makes 36, so you'd have 12 decimal something. That means you have 12 full feet, so we now know that this has to be 12. And we have to figure out how many feet are left over. Well, what is 12 feet in yards? Would you multiply or would you divide? You would multiply. You do 12 times 3, you get 36 yards. Maybe 30. Wow. I wrote it down completely wrong. And I looked at it and it was start again. We have 12 full yards, and we want to know how many feet that is. And there's 3 yards in 3 feet in a yard, so we multiply by 3, we have 36. So maybe underneath here, I'm like, this is 36 feet. How many feet would you have extra if you started with 37? We would have 1 extra. So 37 feet is 12 yards and 1 foot. Why is this important? Well, sometimes when you go to buy something, it's sold in different lengths. Normally, if you were buying baseboards, it would probably be sold in 8-foot lengths if you went to Home Depot, right? So then you would have to figure out how many do I need to buy. 4 would give me 32 feet, not enough. I'd have to buy 5, and I'd have a little bit extra that would be wasted. But I wouldn't be able to do anything about that. This question is saying it's sold by the yard. Okay? So it's $5.99 a yard. Does it make sense that you would have to buy 13 yards? If it's sold by the yard, you have some waste, so then we would take 13, multiply it by $5.99, and before taxes, this would cost you $77.87. You guys know how to do taxes quickly? Okay, you take your $77.87 with taxes, and you would multiply that. Oh, I went to the answers. I'm so tired. 1.12, because you have 5% for GST and 7% for PST. That's the quickest way to add taxes to something. The 0.12 is the 12%, and the 1 is there to say, well, you still have to pay for the $77. $77 plus the 12% taxes, that's what the 1.12, and it would be $87.21. Have a wonderful weekend. Okay, make sure you start on your homework already. Like maybe do a little bit, 10 minutes tonight, just to get it started. Maybe it's exciting and you just get it done right away. So don't forget to take your textbook home over the weekend. You figured it out? Okay. How's the language? Where's the hint? You heard the hint? No. Thank you. Thank you. Thank you. Thanks.
Lucas, amateur to the office, please. Lucas,
Yeah, there's an
amateur
exam
to
at
the
the end of this course.
office.
It's worth 10% of your money. Thank you so much, Austin.
So even if, so like you're really good at seriously, everything else.
Yeah.
And kind of like.
Okay, I'm in one major mark go down there. That's right. So yeah, is that your sweater? Okay.
Oh, I think they went good. I don't know how to use my hand.
All right. Have a great weekend.
You too.
It is this guy.
It is.
Hi!
Hey.
Here I can get a calculator from you since my mom
Okay.
paid for it.
Do you have your receipt?
I don't.
Okay. Because I just need a picture of it, or
Okay.
the secretaries will eventually send me a list, but they haven't done that yet.
Okay.
So she can text you a picture of it.
Yes,
or...
I'll go talk to her.
Okay.
Well, text her.
Awesome.
McDonald to the office, please. Lily McDonald to the office.
Yes. Okay.
Are we supposed to do the last two questions?
The assign, like on the page, yeah, the last ones you can just make up a couple of examples.
For the last
Yeah,
two?
yeah.
And also,
Oh,
I have a
perfect.
question about.
Can I keep this?
Sure, yeah, go ahead.
Perfect. There you go.
Thank you.
For this part, are
Yeah.
we just putting like random numbers?
What I want you to do in this part is like we did in class, the beginning class today, or are you in the afternoon?
Yeah, I'm at that.
We're gonna go over this, but what I want you to do is take this and then say, this goes 3 to the left. So I take this graph and just move it, take these 3 points, move them 3 to the left, and then draw a quick line. Beginning we did points, but then I want you to see if you can find the pattern of what moves things left, right, up, and down.
Okay, so like just use this example.
Yeah, and then help you with it.
Thank you.
You're welcome. And we're gonna go over that at the meeting.
Okay, is it for Mark?
No, it's not for Mark's, just for Pat.
I wanted to, if later, like after 12 or 14,
Yeah.
talk like about the student stuff as well.
Sure. Or you can do it now too, if you like.
I didn't want to.
No, it's okay. Yeah, no, it's fine, it's fine right now. So are you looking for, like, getting some help tutoring with someone in the school?
I spoke to Madam Carrazzo
Yeah.
about it, and she told me that I should like do, I think, homework.
Club?
Yes,
Okay, yeah.
before getting a tutor,
Mm-hmm.
and because I asked her like, can I get a tutor like?
Yeah.
And yeah, so I think I'll just in the first period I just do this homework club.
Homework
And I
club.
just wanted to let you know that.
Okay. And then also you can come at lunch and ask as many questions and I can help you as well.
Thank you.
You're
I mean, I'm not like, it's not everything new. We did like these things of the review, but
Yeah.
I feel
Where are you coming from?
from like
What country?
Italy.
Yeah.
Yes. And so yeah.
Yeah, so then, yeah, there's the homework club after school can help, and if anytime you want, you can come at lunch, you can eat your lunch in here, ask questions, and, yeah,
Okay, thank you so
you're
much.
welcome.
See you on Monday.
Yes, have a good weekend.
Thank you.
How's the laugh coming?
I don't remember like anything.
That's what this does, it makes you remember that you don't remember anything. Which one are you stuck on? So in this notation, so you've got your answer here, 8,580.25. They want you to write it in sort of this is scientific notation. They want something times 10 to the something, and this first number has to be between 1 and 10. So if you have this, I would change it to 8.58, because then it's between 1 and 10. But if you move your decimal over 3 times like that, in scientific notation, that would be times 10 to the 3. Does that make sense? So again, it's not hard, but it's just practicing with, okay, how do I interpret this notation? What are they asking me for? I'm just gonna be eating my lunch, but interrupt me, let me know if there's other things. And if you're asking me that question, you haven't forgot everything.
Can I just give you my notebook, then you can correct it so I can bring it home? But this is mine. I don't wanna write my name on it. You can tell by my writing. You'll know. Not on here,
Why not?
because I don't know my name.
Why don't you write it on the first page then? With a Sharpie?
I'll just put 2 dots and a smiley face and you'll know it's me.
No. Write your name.
I'm not with a Sharpie.
Well, here. Here's a pen. Right there.
That smells really good. Oh, I knew it.
Buttered chicken.
I love buttered chicken.
You should come over, we have a bunch of good stuff.
We make it from scratch.
From like an authentic recipe, because my mom's best friend's sister-in-law is married. No, brother-in-law.
No, sister-in-law is
Sister-in-law
married
is
to
married,
someone from India.
and then their mom showed her how to make it, and then she showed us how to make it. So it's like, cool. Hey, Jenna. I haven't seen you in like, no. And I moved, and I was like, oh. Alright, I'm gonna go home, Dad. You don't need, you know I'm going home, right? You're gonna stay here? Yeah, I only have morning class still here. So. This is very nice.
How are you doing?
Sure. They're going downstairs.
How's the next one coming? Got a question already? Not yet. Mhm. Right, so the radius of the base of the cone, so 1/3 area, and this is the area of the base, right? Times the height. And the area of the base on a cone is what shape? Circle. So the area of a circle, you could put pi r squared in for that. Then you'll be able to solve for the radius. Does that make sense?
And then for the pi r squared, the r is just gonna be this.
No, that's you want to find
Oh,
the
yeah.
radius. The volume is going to be the same volume that you had up here. Because the sphere is then melted down, so it still has the same
Okay.
volume.
Yeah.
So now you can plug that in for the volume, and then you